Hello everyone, welcome back to the channel. Today we'll be talking about how we walk into an environment where so-called read-only user could read everything. We found an AWS Secret Manager which has two giant mega secrets, one for staging, one for production. And inside were long-lived admin key, meaning two CLI command later we got admin access of that particular account. Today we'll be talking about the pattern, how it get abused in the real world, and the fix that actually help. Tell me if this sounds familiar to you. One giant secret per environment. Everything goes in its random environment variable, a database credential, API tokens, and even access key. Then we sprinkle broad list and get permission across multiple users because operation needs it. That convenience quickly turns read only into read the crown jewel. If you can list and get, you can see it all. This isn't one of a bug, it's a design habit. Environment which are split by name, not by boundaries. Permission are broad by default. Secrets are bundled by convenience instead of criticality. And long-lived user keys are parked in the secret manager like they will never leak. Put those together and you had built a privilege escalation machine. From any attacker perspective, this is laughably simple. First, authenticate as any identity with secret manager with read permission. Then list down the mega secret we talked about earlier using secret manager. After that, call this specific environment secret and dump everything into the JSON. And then copy the access key pair from the JSON and set up the profile and confirm it. Call the get caller identity to confirm the profile. If that returns an admin or user with an admin permission, game on. Exfiltrate, persist, or start changing the world. We capture the whole sequence. Access to list those mega secrets, JSON with access keys in it, and the STS proof. Screens are retarded, but the chains are clear. This wasn't theoretical, and once it worked, it is replicable. Impact is massive. With data exfiltration, IAM-based persistence, and infrastructure tampering. Likelihood is also high. Lot of users with get list permissions, mega secrets with high value credentials in it, and long-lived keys waiting to be lifted. When something is this easy and this damaging, it is set in the red zone. Here's the reset. Put production and staging in separate account. Real walls, no sticky notes. Enforce least privileges. Specify tags using environment as staging, for example. Get by exit ARNs and add a deny guardrail for production. Split secrets by app functions and criticality. No more mega secrets. Long-lived keys. Use roles and STS, and if you are running on EKS, use ERSA or pod identity, and configure CloudTrail, GuardDuty, access analyzer so we can see and stop anything sketchy if happen. 3 patterns that help us and we deploy them again and again. First, list by tag. So staging folk does not even see the production secret. Second, get by precise ARNs. No wildcard, no surprises. Third, using deny guardrails that blocks production reads unless the principal specifically says production. So narrow allowed plus broad denied that help misconfiguration bounce off the wall instead of becoming the incident. Alright, so this is how we prove and cross-check that the issue has been fixed or not by going through the following checklist. Checking the staging principle list only staging. Production is invisible. Get secret value works only for exact ARNs proved for that role. No other ARNs has been allowed. No long-lived IAM user keys has been stored in the secret manager. CloudTrail shows deny cross-environment attempts, and if there is an attempt, GuardDuty sending an alert. Making sure access analyzer is clean. This is how we make sure the fix sticks and at least the secret manager does not leak anything. Thanks for sticking with me. If you enjoy this deep dive, don't forget to like, share and subscribe. Thanks for watching.